Loose connections cause fires, guys.
I started the gym last night.
Tesla just went in the cat litter, that's not what I wanted.
Hello everybody, I just finished shooting a video.
Say hello, we've got Vanessa, the lovely lady behind Super Rod and Klein. We've got Craig, the branch manager, Nathan O'Looney Media for everyone that wanted to see his lovely face, and then the man himself.
So I'm off out to do an EICR, but it's a really interesting one. I started it yesterday and I think you'll all be interested to see exactly what it is, because it's not your standard domestic EICR, and you'll see why shortly. So thanks for watching and bear with. I really felt like this moment needed recording. Although you might not believe me, I just pulled into McDonald's and I pulled back out again without ordering anything. If that's not self-control, then I don't know what is. I started the gym last night for the first time in years. My legs have lost all use. Nick Bundy, I'm coming for you. Completely dead to the world. My legs. Stairs are the enemy right now. But guess what? Summer body is loading, right? Winter lockdown body has been with me for far too long. It's one thing being slightly out of shape for what you're used to. It's another thing being slightly out of shape and then having to watch it back on YouTube. It's not very nice. So yeah, back at the gym, and I just thought I'd record that because I'm quite proud of myself. The old Pringle eating Cory. Say goodbye to him. Don't give me Pringles if I come and work at your house. Give me celery sticks and hummus, because that's the new me. When you think of Artisan Electrics, you're going to think of the pinnacle of health. Anyway, just felt like I needed to share that. Right, so I'm sorry if there's horrific road noise right now, but I'm in the old Artisan wagon, and I thought I'd quickly tell you what the job is that I've got at hand. So it's super interesting, I think, for a lot of our viewers, because it's a domestic house. However, it's got 3-phase entering the property, and I started the periodic inspection yesterday. There's 3 consumer units in the house. There's a distribution board and then 2 little sub-mains. I've got to finish off the main section of the house, which I started yesterday. Then I've got to do the 2 sub-mains, but I thought I'd show you around it because there's a few faults. I hope you enjoy. Don't be afraid to pull to shreds my periodic inspection skills. If you think that I'm missing something or I'm doing something wrong, then feel free to pull me up on it. I've been doing a lot more inspections than I probably ever have, to be honest, and I've been finding lots of different ways and different tools that I use now to speed me up a lot, like my crocodile leads I talk about quite a lot, but I'm gonna show you them all. You can see what you think. Another fun little challenge for the day, I'm gonna see how many 90s hip hop and TLC lyrics and references I can get into one video, and if you get them all, then fair play to you, you've done very well, and you should probably get a hobby. This is a really cool view that I've got here. I feel like I want to make the most of it. Don't forget to like, thumbs up and subscribe. It's a massive help to the channel. Anyway, on with the video. So, we've arrived here. I'm gonna grab my testing kit. I'll show you actually exactly what it is that I use. So, I don't tend to bring my whole massive rucksack in because it weighs an absolute ton. So I've got everything I need for testing in that little pull out there. So that will do me nicely. Right, so let's take a little look inside, see what we got. So here's our main head. Got a supply cable coming up. We've got 3-phase in the property. But as you can see, it's a bit of a different setup. So you'll see why this is confusing in a minute. When you take a look inside the consumer unit, you have 3 phases. So you've got your red, yellow and blue phase, or black, brown and grey, or L1, L2, L3, whatever you want to call it. However, when I tested between them, I saw I didn't actually get 400 volts. And there is a reason for that. That's because they're actually using one of the phases as economy 7. So they've got L1 going straight through the meter and out, linking red and blue phase. And then L2 goes into this little remote relay tele switch thing from EDF for economy 7. So I'll show you inside the consumer unit what that actually is looking like in there. Okay, so I'm going to do a few tests. I've already done yesterday on this distribution board all of my dead tests. So I've only got my live tests to do now. Well, I suppose technically installation resistance is a live test in that you're using voltage, but I don't count it as such. So I'm not going to carry out ZS. I'm going to calculate my ZS by working out my R1 plus R2 and adding that onto my ZE value. Something I need to research, which I'm not sure about. Usually when you do potential fault current on a 3-phase system, you take your highest reading and double it. However, we're only using one of the phases, so there is actually only 400 volt potential at certain times. So how do I measure that? Do I record that as double my PFC or PEFC, or do I just keep it as a normal single phase installation? I'm actually not sure. So the only test I've got really left to do on these is the RCD testing inside this consumer unit.
because I didn't want to do it yesterday because it's switching off Wi-Fi and different things, which I did have the jackery, but you know, sometimes you just can't interrupt the power. To take the probes off, I've set my device up. Don't like that we have to take those probes off. Really, they need to make slimmer probe tips, because I don't like having all of that exposed, but it doesn't fit into RCBOs with it on as a problem. So very carefully, I've set my tester to RCD type AC, because these are AC type RCBOs. 30 milliamps at I delta N, and let's go for it. So got it onto auto test, so it's going to test 1 times I delta N, which will be 30 milliamps being injected right now. So we're going to test it at the top of the sine wave at 180 degrees, and then again at 0 degrees, bottom of the sine wave. So that's tripped within the values required. Now I'm testing it at 5 times I delta N, which is 150 milliamps. And again, 180 degrees on the sine wave and 0 degrees on the sine wave. Now we're going to test it at 15 milliamps, which is half of I delta N, or the rated current. And we want that to not trip, because obviously otherwise the device is too sensitive. So now I'm going to do a ramp test. I want to ramp it up and see how much it takes before it trips. So it's tripping at 22.5 milliamps, not bad. There's probably a lot of earth leakage on that circuit already. So let's test it at 0 degrees. And at 0 degrees it tests again at 22.5 milliamps. So it is slightly more sensitive, probably than it needs to be. But you know what, being a little bit more sensitive than you need to be isn't necessarily always a problem, is it? So that is how I would test an RCD or an RCBO. So now I want to go into my certificate, go into sockets downstairs, which is what that one was for. RCDs, so operating current, 30 milliamps, number of poles, it is single pole, no trip at I delta N, yes, half of I delta N, yes, no trip. Operating time, 19.2, 5 times is 18.7. Test button, let's check, yeah, and that one, yeah. So we are good, pass. So that is how I test an RCBO. So I'm going to do the other one, and then I'm going to move on to a little bit more dead testing, because I've not done any dead testing yet on these sockets here, so that'd be good for you guys to see. First step, if I'm doing a periodic inspection like I am on this board here, would be to, I like to get all the paperwork done first. It's like Jordan says, eat your greens first, get all that rubbish stuff out the way. So I've done my ZE, it's fed from here, so it's actually technically ZDB, a kind of ZS on the distribution circuit, and then fill out all the information, all the stuff that I can see on there. The customer said he had an issue with the 2 underfloor heating circuits not working. Well, quite a simple reason for that really. There's nothing at all actually connected into it. I'm going to start with dead tests, so there's no need for the circuits to be live and switched on for this. So what I'm going to do, I'm going to start with my R1 plus R2. So I grabbed myself a little fly lead, probably the biggest time saver that I've ever found so far, and it's just so simple. You know, it's one of those things where you think, why on earth have I not just always done it this way? I've always either put it into the earth bar or I've done other bits and pieces like that. Yes, true, I'm technically measuring parallel paths. I think there will be people that will probably get funny about me doing it this way, but you know what? I just think realistically, in the real world, people test a heck of a lot less thoroughly than not disconnecting earths from the earth bar. So I'm not really too worried. So I have clamped onto there, and now I'm going to clamp onto the earth bar, and then now I'm going to set my tester to low resistance setting, the low resistance ohm meter, and then I want to zero it out. I should really zero it out with these leads, shouldn't I? So I'm going to zero it out with these leads. There we go. So now when I push test, 0. Yeah, so great. Clamp that onto there, clamp that onto the board, and now see you on the other side. So you want to verify beforehand, before turning the power off, that this is definitely the right circuit to be switching off, because otherwise you're going to be in for a bit of a nasty surprise. At the best case, you're going to blow up the fuse on your tester when you've got it set to the low resistance setting. Worst case, you're going to find yourself with a little visit to A&E or the local morgue. My favourite saying in electrical when you're testing is, you know, I don't want no scrubs. Oh, that is the outgoing. Yep. So we've got 0.01, which is a pretty darn low reading. I'll just check everything's tight while I've got it off. I'm pretty happy with that low reading because it is extremely close to the consumer unit and it's a really big cable, so about 0.01 is what I would expect really. The reason why I'm not taking the hub off to actually test at the hub, there is that tiny section of cable there to test, but I think being reasonable, pulling open a siliconed hub to get the reading is not really necessary. So that is the hub all tested. So that is the R1, R2 reading taken on the hub. I tell you what we'll test the ring. I'll show you a little hack that I found. I think I found it on Instagram actually, of a really quick way of testing ring circuits. Okay, so I've switched the circuit off. My first step would be to find all the points that are dead. So that's live, so that's not going to be one of them. I've already tested all of these, so I know that we've got at least 1 point there, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, one in the fridge as well. So I've checked all of these, so I now know how many points I've got. So we'll go across onto number of points and we'll fill in 10. So 10 points. So you'll notice the first question it'll ask you is ring final continuity. So it's asking you for your little R1, little R2 and little Rn, also known as your end-to-end testing on the ring. So we'll do that now. I'll just find the most convenient place. Doesn't really matter where it is. This one looks pretty convenient. Actually no, those socket screws look pretty... you would have already done your samples by this point, so you should have an idea of what kind of condition they're in and what one would be most easy to take off. And in my opinion, I'm actually left-handed, so this is not the easiest thing in the world for me. So we've got the 2 cables and then obviously the spur across to there. What I need to do is separate them like so. Annoyingly, I've used super baggy earth sleeving. I just find it kind of annoying when people twist cables. I mean, to be fair, it's probably a better connection. It's really annoying when you're trying to test. So you just want the little crocodile clips, like so. Right, so we're going to link those out together, and then we're going to go on to R2, zero that out. Great, check it. We want to just test the ends of the ring. Not worried about the spare. 0.56. On the neutral, we expect the neutral to be about the same because they're the same size conductor and they're running the same length. So, what's that? 0.56. We expect this to be about 1.67 times higher because it is a smaller cable. It's a 1.5 mil earth as opposed to 2.5 mil. So, do that. 0.91. So there we go. I'm happy with that. So now I've got our ends to ends. We fill those out. So we go R1 line. Do you remember what it was? It was 0.56 and then 0.56 and then for our R2 it was 0.91. There we go. So now we need to do our cross connections. So the reason why I'm doing it at a socket, I find it way easier than doing it at the consumer unit because it's sometimes really hard to tell what leg is coming from where. In a socket it's just much easier to see it. I want to cross connect my line in CPC from each leg. There we go. And now what we want to do, take that out and plug in to every socket. And we want to watch the readings slowly climb up in resistance the further we get from that socket as we go around, and then slowly lower back down again as we come up. And then if there's any high points, you know that those high points are because of cross connections in the ring. Maybe you've got a figure of 8 ring or some sort of fault like that. So what I want to do is I want to test every point, including when I'm doing this test, I like to test every socket because sometimes you'll find the readings will actually change from socket to socket. Okay, switch across 0.36, 0.38. We'll go across to these sockets just here. Quickly, so I'm causing an absolute wake of destruction here, trying to film and work. .34, 0.36. reinstate everything. And cat litter. So, test that. 0.35. So far, my highest reading has been 0.38. So that's the reading so far that I'll be recording. 0.39. So that's the highest reading that I'll be recording. See, there's quite, sometimes you do get a fair bit of difference between one socket to another. Right, so 0.70. Oh, my test lead just went in the cat litter. That's not what I wanted. And 0.40. So you see the difference between that socket there, 0.7 or 0.63, that socket there, 0.36. So it's quite a big difference. So I'm probably going to take that one off actually and have a little check behind it. Let's have a look. It's probably just bad contacts in the sockets. I mean, they look like kind of B&Q special sockets. Our connections look okay. It's tight, it's twisted together. It's just not great contact in the socket, obviously. So I'll record the highest reading there, which is 0.70. So if you was to do your R1 plus Rn divided by 4 to calculate your target value, that's going to be probably a lot higher than that. But even though it is the fault of a socket, I will record that as the highest reading. 0.46. 0.55, so you see again, 0.1 of an ohm difference, pretty much. 0.65. 0.35. There we go. So that was pretty painless, wasn't it? Just so much easier doing your cross connections, that socket like that, rather than doing it at the consumer unit. Generally, I always tend to just go for R1 plus R2 because although it's a slower process, it's in the long run it's quicker and more thorough. So 0.70, I'm going to record for that for R2. So now the only test left is my lighting and smoke alarms, which I'm going to do in exactly the same fashion and style as I did the hob. I'll just cut to the garage. Okay, so here we are in the garage where you can see we've got a Wilex board, these old 3036 fuses. So it's, if I do that, we have no light. So I'll quickly grab a torch. We've got a 100 milliamp RCCB and then we've got an earth rod out here. So it's cool, it's TT, so the garage equipment is separated from the TN system in the house. So that's cool, that's good to know. See if we can have a look. Oh, they're always done so nicely, these old boards. Such a good era for electrics, the 80s. So you've got this, which is empty, the shower, right. So I think this circuit here runs off above to do a towel rad in the bathroom. And it also has, I presume, some sort of ring inside here. It's actually dropped to a 15, so that is a radial now, isn't it? Yeah. And then a 5 amp lighting circuit. So I'm going to dead test those. And I want to do a test on the main switch here to test the 100 milliamp RCCB. I'm going to try and get Nathan O'Looney style cinematic here. Cinematic slow-mo as the camera sweeps across and then takes a drastic turn to the right. Oh man, Nathan would be so proud of me right now. Back to the job. We have a torch now. To save me balancing my probes, I'm just going to plug the tester into the socket down here. Plug it in. I'm going to do the RCD test like so. So it's a type AC RCD. I want to set it to that. I want to set it to 100 milliamps. Cool. So now I'm going to switch it on. Switch that on. And we'll do an RCD test. I'll take the lights out so we don't damage them from all the switching on and off that we're going to be doing. There we go. Let's test away. So we've got the 100 milliamp TT to comply with the regs. Now we've got RCCB to comply with the regs now that we've got TT. There we go. So while the power is off, I'm just going to flick it off again. Put this fuse back in. Take that back on. Take that on. So I'm checking for things like any signs of thermal damage or any sort of overheating. It all looks good to me. When we replace the distribution board, I don't really think this needs to be replaced. There's nothing wrong with it. I would definitely change that to 30 milliamp, or even better, I'll get rid of this completely, and this supply cable here, I'll protect that back at the consumer unit, and that will then protect all of these circuits. I'll probably just put it on a 32 maybe,
So the only tests now I've got left to do, I'm going to do an R1 plus R2 on that. I'm not going to do a ring continuity because it's been downgraded, and looking at the ring, I can trace out all the cables because they're just all clipped direct to the sockets. So I'm going to do my R1 plus R2 on both of those, do a bit of installation resistance where I can, probably won't test between live and neutral, so we've got a ton of connected loads out of reach. So I'll hold line and neutral together and test against earth on installation resistance. And this is a little interesting find. So we've got this cracked socket here. It's actually cracked from a loose connection. Loose connections cause fires, guys. Like you can see where it's all completely crumbled away from the heat damage, and it's just really loose, and it was on the load side as well, so I only found it from visual inspection. I didn't actually find it from testing, just seeing the thermal damage, the sign of thermal damage, and then opening it up and actually seeing it itself. So it's really important to sample and take actual inspections of things. At the minute this is being left off because it's on the economy 7. It's blinking hot, so when we come back that will definitely want repairing. At the minute as well, there's no thermostat or anything actually controlling this underfloor heating, so we'll be installing like a Nest or some, I've not really decided exactly what yet, but all of these will be switched via thermostats and smart controls, so these will all be going anyway and replaced. But anyway, so I'll show you that.
Right, so I thought I'd do an outro in the van because I love this angle. I think it's awesome. Not the angle of me, but the angle of like the roof rack, the outside. It's like you're sitting on the bonnet. That job went pretty well. I don't think that was too bad at all. Yeah, I finished up the inspection, did all the tests. I found a few faults, a few things I wasn't happy with. Today was literally just to make a report of all of the issues. When we go back, we're adding heating. They've got no radiators, no electric radiators, anything. They just have little plug-in mobile ones that they use from time to time. I'm going to work out a design for some solar panels, see how much of a yield we can get. So we'll have a little think about that. I forgot to show you the garden lights. This is why I need Nathan. Nathan, why have you not come with me? He's with Jordan shooting something in the office. Anyway, the lights, which I'll ping a picture of now. Thank you. The lights had just basically been made off absolutely terribly. It was just an armoured cable that had come in underneath, not stripped back, not waterproof at all. Yeah, it's just really rough. What I will have to do is re-terminate those as well. But anyway, I hope you've enjoyed watching. I hope it's been beneficial, educational in some way. Any questions at all, fire them in the comment section below or send them to me on Instagram. We'll both be more than happy to help. So thank you very much, and take care.